Happy Thursday. Tuesday, we looked at some tricks for trigonometric integrals, right? And then we did a trig sub problem, and then sadly ran out of time. So tonight we're going to finish up trig sub.
The work, the proprietary software that we used to do the assignments, it has this thing called a late pass. Do you factor that in if we decide to use it?
There's no penalty for using late pass. Just make sure that you resubmit so that I know you redid it so I can update your score.
Get one of those the entire semester.
15. So I'm very generous. Dx over x square root of 9 minus 4x squared. Well, this should look familiar. Square root of 9 minus 4x squared. Wasn't that the last problem? So we know how we're going to simplify it first, right? And then we wind up using the same substitution. Right, which was x being 3/2 sine of theta, right? That would mean that dx is 3/2 cosine theta d theta, right?
Yeah.
Derivative. What's the derivative of x?
Yeah.
Right.
Yeah, I think I know one.
And then actual square root will be 3/2 cosine theta. So there's our substitution. Dx gets replaced with 3/2 cosine theta d theta. X gets replaced with 3/2 sine of theta. Square root gets replaced with 3/2 cosine of theta. I don't know why I put a second d theta. I don't need it. One of the 3/2 in the denominator will cancel with the 3/2 in the numerator. Cosine over cosine is 1. We're factoring out a 1 over 3/2, which is 2/3. 2/3 times a half is 1/3. Then we're just left with the antiderivative of d theta over sine theta.
The square root of 9/4 times x squared equals 3/2 cosine.
That's the substitution. If you actually just go ahead and plug 3/2 sine theta in for x, it'll break down to 3/2 cosine theta, right? That'll be 9/4 sine squared. Factor out of 9/4, square root of that's 3/2. You're left with what? 1 minus cosine squared, which is sine squared. Square root of sine squared. Or, I'm sorry, 1 minus sine squared, right? Which is cosine squared. Square root of cosine squared is cosine. How would we evaluate that antiderivative? Remember, sine is cosecant. What is the antiderivative of cosecant? What was it?
Maybe cosecant times cotangent.
You gave me the derivative. I want antiderivative.
Lol.
It's not fair to ask me if I'm asking you, is it? I believe we did it on Tuesday.
Log natural of absolute cosecant x minus cotangent x.
Log of the absolute value cosecant minus cotangent. Then I have to do back substitution. Since cosecant's 1 over sine, and sine is 2/3 of x, cosecant would be 3 over 2x, right? Cotangent, cosine over sine. Right, we're gonna have a 2/3 over 2/3. That's gonna drop out nicely. We're gonna be left with. Oh, I know. I actually want to keep the 2, don't I? Right, because that's going to allow us. Right, this is 3 times, or 3 minus the square root of 9 minus 4x squared all over 2x plus a constant.
Where do you put the 2?
I pulled it into the square root.
Oh.
Right, so square it and then pull it in.
Just the substitution for cotangent complement.
Cosine over sine. Right, so cosine is 2/3 this. Sine is 2/3 this. Right, and all I did was I just canceled out the 1/3 over 1/3. So you're left with 2 times the square root over 2x.
Just to clarify, the X, GX, and value that you pulled from the front is from the rules that we worked out in the video. The rules, like the substitution set rules, not necessarily derived from.
Yeah, so because it's of the form a squared minus x squared, it is x equals a sine theta. Right, the dx just comes from taking that derivative, and then you can easily derive the square root. Right, so I just did all that in the video and said, boom, here's your rule. (16 minus 9x squared) quantity 3/2 over x to the 6th. Kind of resembles square root of a squared minus x squared. Now to factor out a 9. What is 9 to the 3/2 power? 27. There's our antiderivative right now. Narrower of the form square root of a squared minus x squared. What would our x be? What substitution do we use? There needs to be something in front of the sign. What's a? Four thirds. A squared 16/9, right? That means a is 4/3. That would make dx 4/3 cosine theta d theta, and then the square root of 16/9 minus x squared is 4/3 cosine theta. It's going to be fun. (27) times the antiderivative. 16 over 9 minus x squared to the 3/2 power. Is that not the same as the square root of 16/9 minus x squared all cubed? So it's going to be 4/3 cubed times cosine cubed of theta. Write it this way. Over 4/3 sine of theta to the 6th times 4/3 cosine theta d theta. Right? Four thirds cubed times 4/3. 4/3 to the 4th. Divided by 4/3 to the 6th leaves you with 1 over 4/3 squared, right? And then, of course, we have cosine cubed times cosine, which would be cosine to the fourth. $27 times 9. Right, so remember, we're multiplying 27 by 9/16. We get 243 over 16 times the antiderivative. Cosine to the fourth over sine to the sixth. That is going to be a problem. So we're going to have to rewrite it. Cosine to the fourth over sine to the fourth would be cotangent to the fourth, right? We are then left with a 1 over sine squared. Which is cosecant squared. How are we going to do that antiderivative?
Well, the derivative of cotangent is negative cosecant squared. So, I mean, I guess you could do u sub, but you could probably manage to do it without u sub.
No, this is how I would do it, u sub.
I mean, you could try to like hold it in your head without the u.
Well, I mean, that's gonna do, but it is still change a variable. The fact that the derivative of cotangent is cosecant squared breaks us down to essentially u to the fourth du. Right? Right, but the derivative is negative, so I'm gonna have to multiply by a negative. Then the antiderivative of u to the fourth, u to the fifth over 5. That makes this antiderivative negative cotangent to the fifth of theta over 5. Also constant. We need cotangent. $16 times 5. Take care of that. Replace cotangent. Cotangent's cosine over sine, isn't it? Again, I'm going to keep the 4s. So all we're going to cancel out is a 1/3 from the numerator and the denominator. It is 4x. And that is being raised to the 5th power. Oh, wait, is it the 4 I want? No, I'm sorry, it's 3/4, not 4/3. Canceling out the quarters.
Use substitutions for cotangent.
So what is the derivative of cotangent? Anyone? It's negative cosecant squared. There's cosecant squared d theta. Right, so that's du. This is u. And I have to multiply by a negative. Right, because the derivative was negative. What's the antiderivative of u to the fourth? That's all it was. And don't forget our plus c. Leave that alone. We're going to pull this 3 inside the square root. Right, that's done by squaring it first. Right, that'll be the square root of 16 minus 9x squared, all raised to the 5th power. Right, so that is 16 minus 9x squared raised to the 5/2. Three to the 5th. 3 to the 4th is 81.
43.
Right, so 81 times 3 is 243. And there's the antiderivative.
So how did you do that last step?
Which one?
Very last step.
How I got here? 243 over 243 is
Oh,
1, right? And then at that point, you just then multiply straight across. It's 3 to the 5th power. Because remember that 5th power up here distributes to both numerator and denominator. X over the square root of 2x minus x squared. Well, that's not square root of a squared minus x squared. That's not square root of a squared plus x squared. Right, and that's not square root of x squared minus a squared. Oh boy, seems to be a problem. What are we gonna have to do? There's this nice little technique in algebra that was used with quadratics. Her quadratic formula, I think that's for solving.
Yeah, I was thinking about quadratic form.
That's for solving
That's all.
when it equals 0.
I mean, this probably isn't what you want to do, but you could pull out an x from the square root, cancel it, and then like substitute. I guess it would be u equals root x.
Then what would the derivative of that be?
That might make it a problem.
That might actually work. That might actually work. That for right now. Right, then the problem would be that x squared,
U to the fourth.
which is u to the 4th. That does work. Now you have a squared minus u squared. That does work. I think I will continue down this path. Because the next one is going to be guaranteed. Do the trick I want to show. I like this. It's not what I did in my notes, but that's okay. So what would the substitution be? U equals what? What is it? What is A? What's A squared? So A is root 2. So you're not bad at this. All right, that makes du root 2 cosine theta d theta. And then the square root of 2 minus u squared be root 2 cosine theta. U to the 4th, we're going to get 4 sine to the 4th. Right, root 2 to the 4th power. Over root 2 cosine theta times root 2 cosine theta. D theta. Which is 8 times the antiderivative sine to the 4th theta d theta. How are we going to find that antiderivative? You have two methods at your disposal. I, of course, have a third method, plug it into a calculator, but we can't do that just yet.
You're making it the sine squared.
And how would that help you?
Like 1/2 times 1 minus cosine 2x.
Why just one? So instead of doing sine squared times sine squared, do sine squared squared. Right, and then do the reduction identity on sine. The other method is to use the reduction formula on sine, right? The antiderivative reduction formula, which I personally don't like using that if I don't have to. So the technique I immediately thought of was that one, use the sine reduction identity. Right. 1 minus cosine 2 theta over 2 all squared. That means we're going to be able to factor out a 1/4. Which will leave us with 2 on the outside. Expand it out. 1 minus 2 cosine 2 theta plus cosine squared 2 theta. Now what?
Sine reduction formula,
Or on what?
cosine squared of 2 theta.
So do you want the formula or the identity?
Uh,
Formula would be the antiderivative, identity would be the actual trig identity.
I guess identity.
So use the cosine reduction identity, which says what? Cosine squared of x is equal to what?
1 plus cosine of 2 theta over 2. So because we have 2 theta here, it would be 4 theta.
And so cosine squared of 2 theta would become 1 plus cosine 4 theta all over 2. One plus a half. 3 halves. Also could have just factored out a 1/2, but I don't know if that's what I want to do. You know what? Might as well distribute that 2 through just to get rid of the fractions. Right, since that 2 is already on the outside. What do we get as an antiderivative? I don't think I screwed up any arithmetic anywhere. Did I? Root 2 to the 4th is definitely 4. 4 times 2 is definitely 8. And I needed that 2 out there. Nope. Okay, so maybe my notes I screwed up. So what is that antiderivative? Go term by term. What's the first term of our antiderivative? What is it? 3 theta. What's the second term? What's the third term? What is it? You're missing something. Over 4. And then plus a constant.
Plus over 4.
Because it's cosine of 4 theta, right? So u is 4 theta. D would be 4, right? But we don't have a 40 theta, so we have to multiply by 1/4.
That is,
Yes.
I like it.
We have to try and write this back in terms of x, right? But we have a problem. We don't know anything about sine of 2 theta. We know sine of theta. Likewise, we know nothing about sine of 4 theta. We have to write these as trig functions of just theta.
So use the sine of 2 theta equals 2 times sine theta cosine theta.
Then sine of 4 theta would be 2 sine 2 theta cosine 2 theta, right? Go away. We have to pick one for cosine of 2 theta. I'm going to stick with 1 minus 2 sine squared. I think it's that. Yeah, because it'd be 2 cosine squared minus 1, right? And then the other one's 1 minus 2 sine squared. Just to make it look like the sine reduction. We have -4 plus 1. nowhere near what I got in my notes, but it should simplify out to be the same. Perfect. Now we can go and do the replacements. This is our first time actually just getting a theta, right? Not trig of a theta. Sine theta, u over root 2. So what's theta? Sine, we said, was u over root 2. Cosine. Square root of 2 minus u squared over square root of 2. Sine cubed. U cubed over 2 root 2. And then cosine again. Plus C. Simplify everything. Root 2 times root 2 is 2. Two cancels out. Then we get root 2 times root 2, which is 2. That has the same denominator, so why not just write it as a single fraction? However, what was our independent variable? This is u. So we have to do one more back substitution. What did we say u was? Which feels like ages ago, right?
Thanks.
I'm also going to use properties of square roots to say root x over root 2 is just square root of x over 2. I mean, that just looks hideous. So let's make it look a little bit nicer. Okay. X to the 3 halves is x root x, right? I'm gonna say there's our antiderivative. Which is very close to what I have in my notes, because I didn't do it this way. And I'm sure that I can simplify the inverse sine of root x over 2 to be what I have. So I'm going to say that's correct.
So, I mean, looking at the original function, our domain for x is 0 to 4. But then in our antiderivative here, our domain for x is going to be, we can't put in numbers near the top of that because of the inverse sign. Right?
Why can't you put a number to the
Because
top
if you
of it?
put, like, let's say something really close to 4, and you'll get inverse sine of root 2, which is out of range.
True. So the domain would just be adjusted. The domain of the antiderivative is not necessarily the same as, right, when you write it as a function. The domain can change. Right, so you'd have to restrict actually your original domain here. Right, which we kind of just ignore. It will be important later when we deal with definite integrals. So you definitely can't have 0, I agree. You sure 0 to 4? 0 to 2, isn't it?
Oh yeah, I did.
Because 2 minus 2 is 0.
I did the math wrong.
So if I did everything right, it should actually still be the same domain.
Yeah.
Perfect. That eliminates that problem. Love when problems are easily solved. By the way, how much calculus is actually in this problem? That was your calculus? Everything else was algebra? Calculus is easy. Algebra is hard. 90% of calculus is algebra. And that was a short problem. Wait to get a problem that takes you 3 hours. Only to wind up with an answer being 0. And then you just kind of throw your work against the wall and say, you rotten bleepity bleep. Dx over the quantity 4x squared minus 24x plus 27, all raised to the 3/2 power. Well, that's definitely not one of the 3 forms. What are we going to have to do? U sub will not work in this one. Not right now.
Discussing you calling one factor of the bottom part.
What do you mean factor out?
Maybe.
Well, quadratic formula only works if you set it equal to 0 to try to solve, which is not what we want.
Square.
Complete the square. It is one of those algebra techniques that is way more useful than you realize. This will not be the last time you need to complete the square. Before that, factor out a 4 from the first two terms. Makes completing the square a lot easier. Complete the square on x squared minus 6x. I know, I'm evil for making you think all the way back to algebra. How do you complete the square? Because at this point, everyone goes, I really should have paid attention in algebra.
You take the half of b and then you square it.
So for this problem, b is what?
-6. So -3 squared is 9.
And what do you do with that 9?
You put it at the end, and then you'll have to put a corresponding number to balance it out somewhere else.
Which is what?
Well, we're in that thing, so 36.
I'm gonna not jump that far yet, but yes, you're right, it'd be minus 36. Right, you're not allowed to add by any number but 0. So since we want a 9, just put in plus 9 minus 9. Oh, look, we've added 0, so we haven't changed anything. And the whole reason to do that, x squared minus 6x plus 9 is x minus 3 squared. 4 times -9, -36, add that to 27. You should get minus 9. I'll raise the 3/2. We are not going to like that 4 being there, so why not just factor it out? What's 4 to the 3/2? That is still not in one of the 3 forms. What do we do? I agree with the square root cubed. Do not agree with factoring out the 9/4 because that is a squared, right? So that's fine.
You sub.
What's u?
X minus 3.
Let u be x minus 3. Then you have square root of u squared minus a squared, which is one of the three forms. For the form square root of u squared minus a squared, what is the substitution we make? So u is going to be what for our problem? Again, you know what a squared is. Yeah, but that's not what you want, right? You said it was a secant. What's a squared? Was it? How'd you get that? A is not 9/4. A squared is 9/4. So a would be 3/2. Derivative of secant. Secant and tangent. I think you mean times.
Tangent of theta.
And then that square root would be 3/2 tangent. And again, if you just plug in 3/2 secant for u and simplify it, you'll get 3/2 tangent of theta. I'm just going to point out that we still have not done calculus. Plugging everything in. Right, du 3/2 secant theta tangent theta d theta. Denominator, isn't that going to be 3/2 tangent of theta all cubed? We're going to be factoring out a 1/3 squared, right? Because one of the 3/2 in the denominator cancel with the one in the numerator. So 3/2 squared, 9/4. 1 over that is 4/9. 4/8 is a half. We'll be left with 1/18 on the outside. Tangent over tangent cubed is 1 over tan squared, right? We're left with secant over tangent squared. How would we have to do that antiderivative?
up until side and side.
So if you did that, what would you get? You're right, but I'm going to do it simpler. 1 over tangent is cotangent, which is cosine over sine. And that simplifies. To what? Cosine over sine squared? Do it that way. How would you go about this? There are actually 2 methods. That's one, and that's ultimately the way I'm going to go. What's the other? That would leave. How'd that help you?
Maybe if you did that and then you said natural log of that. So that way it's, wait, no, because then you have
That wouldn't
the
work.
wrong thing in the top.
You went way too far. It is a change of variable. What's the derivative sign? So you can just let W be sine. And you'd have 1 over W squared. But that would be a third change of variable in one problem. I don't want to do that. I'm going to go the root of cosine over sine squared is cotangent times cosecant. What's the antiderivative of cotangent times cosecant? Right, so again, yeah. It's negative cosecant. Hey, look, we finally did calculus. That's nice.
Just before I did that.
I would argue I already derived that for you in the videos, so no calculus was needed.
Well, you could say
Like, I already did the calculus ahead of time, so that whole thing is just your substitution. That's how I would argue it. So you didn't actually really need to do calculus until we got to here. But even if we did that, okay, let's just say we did that, okay, then that's calculus right there. And then this was calculus, and that was it. And they were easy. They love calculus. It's so easy. It's the algebra that's difficult. We're not done. We now need to write cosecant of theta as a function of u. We don't have anything about cosecant in the substitution. We have nothing about sine either. That's a problem. That's okay, because we're all very proficient in trigonometry. We love trig. At least two of you better like trig. You had me for Calc 1 and now Calc 2, so. God help you if you have me for Calc 3. Let's say that's theta. Secant theta is 2/3 u. In right triangle trigonometry, how is secant of theta defined? Hypotenuse over adjacent. You could have just as easily said the hypotenuse is 2/3 u, the adjacent be 1 in that case. But why introduce fractions when we don't have to, right? What is that missing length? If I let the adjacent be 1, I would say yes. Right, or would I have to do? No, I'd have to do the hypotenuse as u. Right, and then the adjacent would be 3/2. Right, because you got, I think I know how you got it, right? You got it from tangent theta, right? So it'd be 2/3 the square root of that. Use it from just the right triangle we have here. And what do you get?
Root 4u squared minus 9.
Square root of 4u squared minus 9. How is cosecant defined in terms of right triangle trigonometry? There's cosecant as a function of u. But wait, there's more. Our independent variable is x, not u. What do we say u was? X minus 3. Oh, look at that. Okay, so that 2 is going to cancel out. That's nice. That is 4u squared minus 9, no? And how did we get that? From that, no? So 4u squared minus 9 would be 4x squared minus 24x plus 27. Right, and then finally just writing it to be a single fraction. And let's get rid of that negative. And there is your antiderivative. Good news. As long as you apply the appropriate substitution and you take antiderivatives correctly, that's 6 out of 10 points, regardless of any of your other work. So if you get the arithmetic or algebra wrong, depending on what you got wrong and how bad it was, up to 4 points off, which isn't terrible. So if it has not become clear yet, review your trig, review your algebra if you're rusty. The algebra is only going to get worse. Especially with what we do next week. Next week is partial fraction decomposition, which is like 99% algebra. Questions on trig sub?
Earlier, I guess that was yesterday, well, not yet, Tuesday, when you had square root of x squared minus a squared, etc. And you had a specific trig function for each of those. Why can you only use that trig function as opposed to any of the other ones that a Pythagorean identity would like make work out?
No, which other ones would you use? So you're saying like maybe a cosine instead
Yeah.
of a sine? Tradition. You'd have to go back to whoever came up with these substitutions and ask them why they chose these three.
And for say,
I would probably say the reasoning is because of negatives popping in with the others, right? If you take the derivative of cosine, you get a negative sign. The same thing would happen with the other two. If you took the derivative, you'd wind up with a negative if you use the other variation. So that would be my guess as to why you use these three. Yes, you could, and it would still work. You just have that net, you'd have that extra negative floating around. So to avoid that, we use these three. That would be my guess, but I can't go back that far and get into their mind. And by the way, there's also a technique known as hyperbolic substitution for the exact same three. We use hyperbolic functions instead of trig functions. Lucky for you, I'm not covering hyperbolic functions.
This first problem.
There it is.
Not this one. 4x squared plus 24 or
Oh, the one we just did.
that I'm missing as to how you got the bottom half to look like
To be in the form.
yeah, to be in that form necessary for trig sub. Could you do that one more time for me?
Right, so here we have to complete the square. Right, so the first thing I did was factor out a 4 from the first two. Then complete the square on this bit here. Right, do you remember completing the square?
Yeah.
Right, take half and square it. Half of 6 is 3, squared is 9. So add 9, subtract 9. Right, because you can only add 0, right? You can't just add 9 to something, it changes it.
Oh,
But if you add 0 to it, it doesn't change.
that must keep.
Well, usually it's equal, so you add it to the other side as well. Right here, there isn't an equality, right? So, see, and that's why when I actually do algebra, I don't teach it by adding it to the other side. I do plus minus, and then add it to the other side at the end. Is that's what you were missing?
I mean, I'm missing a lot more than that, but that's. That,
Welcome to
that'll do
calculus.
for now.
Welcome to trig sub. You'll get the hang of it.
Yeah.
Just takes time. And like I said, this is the hardest topic all semester. And I figure I might as well get you hooked on alcohol early. If you're legal age. If you're under 21, I do not condone you getting alcohol. Anything else?
Really long.
That'd be this one.
I know that we've had to make sure that we had to get rid of the 4 theta. How did multiplying against the derivative do that? I was confused on why we multiplied all the sine 2 thetas by cosine.
Talking about how I got to this step. Identity. Sine of 2 theta is 2 sine theta cosine theta. That's a trig identity. So that's just the double angle identity for sine.
On the sheet teams.
All except for the product to sum identities. But I introduced the 3 last class. So just write those down on that sheet and then you have every trig identity. I don't know why they don't include the product of sums, to be honest. I don't think they're labeled though. I don't remember if they like label like here, like these are the double angles. I don't know if they do that, but they are on there. They do?
If you wanted to memorize less trig identities, but you notice that by taking the derivative of some of them, you get others, how many ones would you have to memorize?
That is a whole different branch that I didn't study. That's dealing with differential geometry. Because you're talking about differentiating trig identities. Yeah, that's completely different. I wouldn't worry about those. That's grad level. So just the identities that we have. And you don't really have to memorize them. If you're going to memorize, the ones I would personally recommend memorization, obviously the Pythagorean identities, the double angle identities, and the reduction. Those would be the ones that are used most often. Technically, this is all a lie, right? Because we're supposed to be in spherical geometry, but again, that's a whole different ball game. Yeah, a couple weeks, right? The entire week. It's take home. I don't give it in class. So it'll be posted the first day we meet and be due the following weeks. Right, so it'll be posted that Tuesday and it'll be due the following Tuesday. I'm just gonna warn you, everyone's always happy about take-home exams, yet I always still get a lot of Fs. Take-home exams are actually generally a lot harder than in class because they're take-home. So don't think you can just get away with not studying. You're still gonna have to study.
We can check all your answers with like a calculator or something.
Well, you're allowed to use a calculator, but for this one, you're gonna have to show all the work.
Well, yeah, but if then.
Yeah, you can check
know
your
you
answer with
got
a
it right,
calculator.
though, at the end.
Yeah, you can check it with a calculator. That's fine.
Okay, do you have any like a list of example problems we could see on the test, or should we just go through everything that we do here?
Everything that we've done, including the problems I assign in the textbook. Rule of thumb, anything we cover in class, anything I mention in class, and anything in the textbook is fair game for a test. And that's true for every single class. The problems themselves? No, they're on teams. The written out solutions are not. Right, those you have to actually pay attention for. Or go back and watch the recording. Love it. Everyone's panicking and we're not even halfway through techniques yet. Partial fractions will be like the kind of like the cutoff point. That's the halfway point. Is it? No, this might have actually been the halfway point. I think there's only 3 things left I have to cover. Partial fraction decomposition. Oh, no, that's right. Okay. Tables and cast, that's easy. Then it's numerical and improper. Yeah, so we're about halfway through. Method of partial fractions will be the halfway point.
Do you mind if we use scrap paper on quizzes?
There's a problem with scrap paper. If you don't turn it in,
Well,
and
if
most
you
of your
turn
work's
it in.
on it, just make sure your name's on it.
Okay.
Other take like quiz tests, right?
You can do 1 reattempt per calendar week. You have to fill out a form. And then it'll probably be in person, but I'll ask you when you want to do it.
Didn't you say something? This that entire thing, but I got.
Oh, that really sucks, doesn't it? How much is it worth to you?
A lot, because I should probably.
A lot? $20 million
I've got.
in cash. In cash. See, that's the wrong attitude. With that attitude, you definitely won't. You can reattempt quizzes and tests. You just have to fill out a form, which is on Teams, or the links in the syllabus. That is the goal, which means that each individual quiz is not really weighted that heavily. If I give 20 throughout the semester, each quiz is 0.5%. Right. So out of 100 points, each one's only worth 0.5 point, which is like nothing. Yeah. Anything else?